Namaste. Welcome to the Indian Knowledge Systems primer course for children. In the previous session, we saw how to construct a square with the use of a rope and nails. Now, we will do two more simple activities. First is the activity to add the areas of two unequal squares and construct a new square whose area would be its sum. Instead of computing, this is simply done geometrically. We will learn how. Let us say we have these two square cuts which are different from each other in size. You can see it, right? Now, we shall see how to add them together. What do we do for that? First, place the smaller square over the larger square like this. Then, draw a line along the smaller side of the square onto the larger square like this. Now, draw a diagonal line connecting the corner of the bigger square to the other tip of the newly drawn line that we did in the previous step. Now, taking the newly drawn diagonal line, that is this line, as the length, we construct a square. The area of this square will be perfectly equal to the sum of the areas of the given two squares, that is this square and this one. It's wonderful, right? Okay. Now, what if we were to geometrically subtract two squares? We will learn the steps for it. Again, place the smaller square over the larger square like this. Then, the same way, draw a line along the smaller side of the square onto the larger square. Now, draw an arc with the bottom corner of the smaller square as the center. So, last time we took that corner, this time we are taking this corner as the center and height of the bigger square as the radius, that is this length. We are taking it as the radius and then draw an arc that will touch the larger square side at one point like this. Now, taking this as the length, we draw a square. This square would be the result difference of the given two squares. This is how we do the addition and the subtraction of the squares, not computationally but geometrically. The geometric constructions of chittis or Vedis were not just restricted to circles and squares. More complex and nuanced chittis were built. Some of the different kinds that have been described in the texts are this Chaturashra Shyana Chitti. This is a falcon-shaped chitti with straight wings. Then we have Vakprapaksha Shyana Chitti. This is also a falcon-shaped chitti. This is with a bent wings. Then we have Kanka Chitti. This chitti is shaped like a hawk bird with curved wings and tail. Then we have Alaja Chitti. This one, it looks like a kind of a bird called Alaja. Then we have Ratha Chakra Chitti. Ratha means chariot, Chakra means wheel. So, this is a chariot wheel shaped chitti. Then we have Kurma Chitti. Kurma means a tortoise. This chitti is in the shape of a tortoise. Here is the flying falcon shaped chitti, that is Shyana Chitti with bent wings. This picture shows the structural plan of the first layer and the second layer. These were the building blocks. These bricks had to be perfectly constructed to get a geometric chiti. And see, there were multiple layers. Some of these chitis were built in 5 layers. One layer is built for sacrifice made this year. Next year, right on top of previously built layer, a new layer is built. The structural plan for the first, third and fifth layer are the same, whereas the second and fourth had a different structural plan. Each layer constituted construction with 200 bricks precisely. Here are some of the images of the chitis. Kurma chiti, that is in the shape of a tortoise. Then Ratha Chakra chiti. We have this in the shape of a chariot wheel. Then we have a chiti with intricate square pattern. Now let us look at the achievements of the Vedic era. They did construction of the rectilinear chitis, that is, they were in the shape of square, trapezia, etc. And they did chitis also in the shape of circles, Vedis, that is, curvilinear chitis. They gave geometric principles and practical application of them. They did the transformation of one geometric object into another geometric object by applying these principles, and these were all area preserving transformations. Then they obtained the value of surds. Surds means irrational numbers like √2, √3, etc. They obtained the values of these surds by the means of geometric construction. Then estimating the values of surds in the form of a sequence of rational numbers. Different methods proposed by scholars to arrive at these expressions for the values of the surds, in particular √2 and pi. Now let me show you. Bodhayana gave the value of √2 as a sequence of rational numbers. So he gave √2 is equal to 1 plus 1 by 3 plus 1 by 3 into 4 minus 1 divided by 3 into 4 into 34. Now, if you compute this, you will get the value of √2 correct to 6 decimal places. That is 1.41421. Interesting, isn't it? Imagine our mathematics was this sophisticated 2800 years ago. Amazing, isn't it? All these constructions led to the knowledge of various geometric principles which we read as theorems today. One such theorem that we learn today as Pythagorean theorem should actually be called as Shulba theorem. Later, texts call this as Bhujakoti Karna Nyaya. Way before the Pythagorean school in the West, here in the Indian civilization, Bodhayana has given this through this sutra. Dirgha chaturashrasya akshnaya rajjuhu tiryangmani parshvamani cha yat prithak bhute kurutaha tadubhayam karoti. What does this mean? Dirgha chaturashram, which means an elongated four-sided figure, that is a rectangle. Akshnaya rajjuhu, which means a diagonal rope. Parshvamani means the measure of the lateral side, that is this. Tiriyangmani means the measure of the perpendicular side, that is this. Now, let us take this length to be A and this length to be B and the length of the diagonal be C. Now, let us draw 3 squares, that is one with side as A, that is A square. The other with side as B, that is B square. Then, with side as C, we draw C square. Now, this sutra is saying that the sum of the areas of A square and B square will be equal to C square. So, this is a geometric way of putting that in a right angle triangle, the square of the two perpendicular sides will be equal to the square of the hypotenuse. Isn't this very interesting? Bodhayana, in his very next verse, presents a few values that obey this law. Tasam trikachatushkayoho. So, he says a rectangle of sides 3 and 4 will obey this law. That is, 3 square plus 4 square will give 5 square. Dwadashika panchikayoho, which means 12 and 5. So, 5 square and 12 square will give us 13 square. Panchadashikashtikayoho, which means 15 and 8. So, 15 square and 8 square will give us 17 square. Saptika chaturvimshikayoho, which means 7 and 24. So, 7 square and 24 square will give 25 square. Dwadashika panchatrimshikayoho. Dwadashika means 12 and panchatrimshika means 35. So, the square of these two numbers will give us 37 square. Lastly, Panchadashika Shatrimshikayoho. Panchadashika means 15 and Shatrimshika is 36. The square of these two numbers will give us a square number, that is 39 square. Just to appreciate the vast contents in Shulba Sutras, scholars have enumerated a list of such theorems in the texts. The diagonals of a rectangle bisect each other. They divide the rectangle into 4 parts, 2 and 2, that is vertically opposite, all of which are equal in all respects. The diagonals of a rhombus bisect each other at right angles. An isosceles triangle is divided into 2 equal halves by the line joining the vertex to the middle point of the base. The area of a square formed by joining the middle points of the sides of a square is half that of the original one. A quadrilateral formed by the lines joining the middle points of the sides of a rectangle is a rhombus whose area is half that of the rectangle. A parallelogram and rectangle on the same base within the same parallels have the same area. The square on the hypotenuse of the right angle triangle is equal to the sum of the squares on the two sides. If the sum of the squares on the two sides of a triangle be equal to the square on the third side, then the triangle is right angled. Based on the activities that we saw in the Vedic geometry, you can try these on your own. Thank you. Dhanyavadaha.